Okay, in this video, we are going to look at inductance. Inductance is the tendency of an electrical conductor to oppose a change in the electric current flowing through it. Okay, L is used to represent the inductance, and Henry is the SI unit of inductance. Okay, so the tendency to oppose change in electric current. Now remember that the tendency to oppose current flowing in the conductor is what we call resistance. But inductance here is the opposition to the change in current. Now inductance is classified as two types. We have self-inductance and we have mutual inductance. So let's quickly see them. Now self-inductance is defined as the phenomenon in which a change in electric current in a circuit produces an induced EMF in the same circuit. So that the same circuit that has the change in electric current, EMF is induced in the same circuit. That's self-inductance. Now, based on what we treated, according to Faraday's and Lenz's law, EMF is N number of turns multiplied by the rate of change of flux. Okay. Now, but we should know here now that number of turns times change in flux is equal to L inductance times di. So we can also say that EMF is also L di over dt. From that, if we equate the two, it means that the inductance is number of turns times the flux, magnetic flux, divided by current. We should note that. Then in addition, we should also know that the energy stored in an inductor is half Li squared. Okay, so but mutual inductance M is a property whereby an EMF is induced in a circuit by a change in flux due to a current changing in an adjacent circuit. This is the basic operating principles in transformers generator. So the change in flux in one coil causes an induced EMF in another coil. Okay, that's the difference. In self-inductance, the change in flux induces EMF in itself, but this in another coil. So when two coils are linked, the changing current in one coil induces an EMF in the second coil, and this is called mutual inductance, M. Now the induced EMF by coil B, which is EB, by changing current in coil A is given as, so the EMF here will be equal to M, which is the mutual inductance, times the IA, change in current in coil A, all over T. Beautiful. So let's see a question here. This question says an induced EMF of 2.0 volts is measured across a coil of 50 closely wound turns, while the current through it increases uniformly from 0.0 to 5 amperes in 0.1 seconds. A, what is the self-inductance in the coil? Okay. Then B says with the current at 5 amperes, what is the flux through each turn of the coil? Then C says the energy stored in inductor with a current of 5 amperes. Okay, the first one here we're asked to find inductance, but we're given EMF, so you can use this formula. Your EMF is 2.0, we don't know what L is, times the change in current. Current change, that means 5 minus 0 divided by 0.1. Change in current is 5 minus 0 divided by 0.1. That will give us 50. So this will be 50. So my L now will be 2.0 divided by 50. So if we have 2 divided by 50, it's going to give us 0.04. So the answer is 0.04 Henry. That's the answer to the first question. Now the second question says we should, with a current of, as the current is 5 amperes, what is the flux through each turns of the coil? Remember that we said that inductance is also N phi all over I. Your inductance, we just got it to be 0.04. equal to the number of turns is 50. Then we are looking for file divided by the current is 5 amperes. So this will be, the flux will be 0.04 times 5 divided by 50. Okay, so that will give us 0.004 Weber. WB 0.004 Weber. Okay, so the C part says the energy stored in the inductor. We know that energy stored is half Li squared. So that will be half times the L is 0.04. Then the current is 5, so 5 squared. So by the time we multiply half times 0.04 times 5, that will give us 0.5. So the energy stored here is 0.5 joules. This is beautiful. Okay. The next question has to do with mutual inductance. Calculate the mutual inductance between two coils when a current changing at 200 amperes per second in one coil induces an EMF of 1.5 volts in the other. Okay, in this case here, we can use this formula. The induced EMF is simply 1.5. We are looking for the mutual inductance. The rate of change of current is already 200 amperes per second. So that means M now will be 1.5 divided by 200. So if we do 1.5 divided by 200, we're going to get 0.0075. Okay, thank you, Henry. Thank you very much. Have a nice time.